Hi everyone and welcome back. Maths with Mr. Simons. In this grade 12 probability lesson, we will be looking again at the fundamental counting principles, but we will be looking at letters and digit combinations. Specifically, example on number plates and one on coding or passwords, whichever way you want to look at it. Alright, as I said, this is just example to introduce you. We will do it more in detail once we do the exam questions. So the exam questions, you will pick up other small tricks and so on to solve it. Before we do that, we need to understand the basics. Right, so number plates, FCP, much just short for fundamental counting principle. So number one, how many different standard old style Gauteng number plates were possible? The format was 3 alphabetic characters, excluding Q and the vowels A, E, I, O, U, followed by 3 numeric digits. So examples, CCC000, one option, STR781 is another, set123 is not an option because I have A in it, right, which is one of the letters excluded. So I assume you know in the alphabet we have 26 letters, so if I take 1, 2, 3, 4, 5, 6 out, I have 20 available to me. You say numeric digits, we're always going from 0 to 9. So therefore from 0 to 9 we have 10 digits. So therefore exclude 6 letters, we have 20 and 10 numbers from 0 to 9. If you count from 0 to 9, you'll get 10. So 3 letters, so I have a letter, and then I have a digit I'm choosing. So my letters, I have 20, then 20 again, then 20 again, right? For my digits, I have 10 times 10 times 10. Therefore, using fundamental counting principle, number plates available, we have 20 times 20 times 20 times 10 times 10 times 10. So all in all, for the old style Gauteng number plates, we had 8 million number plates available. Meaning all in all, we had 8 million cars that could have this number plates in Gauteng. But you know we changed to a new format, so I assume we reached 8 million and we had to cater for the new cars. But we will do that under the exam questions, right? Let's look at another example. Right, now, how many different codes can be generated? If a code must consist out of 7 characters, namely 3 letters and 4 numbers. So there, fundamental counting principle, passwords or coding. Alright? So letters and numbers may be repeated, meaning I may use a letter more than once, so I can have A. Right? If we said letters may not be repeated, and if I use A, then the second letter must be B, C, T, etc. Once I use another letter, I can't use it again. Same thing with digits. Right? So again, 3 letters, I have letter, and then I have digit. Right? So if I had to make a code, I have 26 letters available, maybe repeated, so I have 26 again. Maybe repeated, I have another 26 available. Same with the digits. For the first selection, I have 10 selections available from 0 to 9. Second selection, I may repeat it, so again I have 10 selections available, then 10, then 10. Right, so we should have 26 and 10 numbers available. Therefore, using fundamental counting principle, codes available, 26 times 26 times 26 times 10 times 10 times 10 times 10 gives me 175,760,000 different codes available to me, combinations. So somebody tried to crack, say that was a password. He has to look at 175,760, 175,760,000 different possible combinations, which sounds a lot, but it's not a lot, taking into account the software the guys have developed nowadays. Right, now, B letters may be repeated, so I may use a letter more than once, but not numbers. So the numbers I may not repeat, and 0 may not be used. So I still have 26 letters of the alphabet available, but if I include 0, we only have 9 numbers, so 1 to 9. So furthermore, numbers may not be repeated, therefore we have 9 numbers available for first choice. then 8 for the second, and so we would continue decreasing as we go along. So using fundamental, letters may be repeated. So for my 3 letters, I still have 26 times 26 times 26. Right, for my numbers, 0 is excluded. So my first number is, I have 9 possible choices. Once I've used that number, I can't use it again. So then I have 8 possible choices left. Once I've taken that one, now I only have 7 left. And then I have 6 left. So my number of codes, 26 times 26 times 26 times 9 times 8 times 7 times 6, which gives me 53,149,824 different choices available to me. So hope you follow, hope you understand. Right, let's look at the third. Alright, letters and numbers may not be repeated. So using fundamental counting principle, if I have 26 letters available, I use 1. For the second choice, I can't use the letter I chose in the first. So now I have 25 left, and then I have 24 left. So 26 times 25 times 24. Right, but for my numbers, it's still 0 is included now. They didn't say it's excluded, so I have 10 times 9 times 8 times 7, which then gives me 78,624,000. Right, so I hope you understand. This is, as I say, it's just the introduction so you can follow and understand how we use fundamental counting principle. The first slide we done menus. Now we looked at passwords and number plates, and so we're going to go along looking at books and word examples, etc. We have many different ways we test fundamental counting principle, and later on we'll also bring in factorial notation. If you enjoyed the lesson, you like it, please subscribe. Right, so you can stay up to date with the new videos that will be uploaded weekly. Right, God bless. Bye.